And good evening, YouTube. Here we are again, and welcome to day 10 of what would have been our 10th day of Life After Calculus 2017 if we had the time. But I guess I'm just doing a summary on my blog. Here we go, and on YouTube. Alright, so here's a little question from Pre-Calc near the end of the matrix unit, a nice little application of matrices. Just like day 9 was a nice little application of cross product of two vectors, finding the area of a polygon of any shape. Well, here's a nice application of matrices. So it's all about encryption. So make up a 3x3 matrix to encrypt and decrypt the secret message of your choice. Let A equal 1, B equal 2, and so forth. Okay? Alright, so the idea is this. Let's say you want to encrypt a message. Okay, so today in this video, Life After Calculus Day 10A, I'm going to do it without any calculator or Sage or anything. Just show you how to do it. But it's easier to do with a 2x2 matrix, so let's see how that works. Alright, so let's say I want to encrypt the message, let's see, I love you. Okay, now how are we going to do that? Well, we're going to take that list that we had, and we're going to look up the letter I is N, the letter L is 12, and so forth. So, let's see. So, I is 9. Let's make spaces 0. Let's make this 0, not an O, right? L is 12. O is 15. V is 22. E is 5. Space is 0 again. Y is 25. I have the list in front of me, don't worry. Here's 0. 25. The letter O is 15 again. And the letter U is 21. Okay. So if I do this with a 2x2 matrix, what I'm going to do is I'm going to take a 1 row by 2 column matrix. So just taking two letters, in this case 9 and 0, and multiplying it by a 2x2 matrix. Okay, so let's say 1, 2, 3, 4. Now remember, you can multiply a 1 by 2 matrix times a 2 by 2 matrix if the number of columns of the left-hand matrix matches the number of rows of the right-hand matrix. If these match, your answer has this dimension, 1 row and 2 columns. So how do you do it? Well, to get the first row, first column entry, you take the first row times the first column. And sort of a dot product, okay? So 9 times 1 is 9, 0 times 3 is 0, 9 plus 0 is 9. And to get the first row, second entry, what are you going to do is you're going to take the first row and then the second column and a dot product. So 9 times 2 is 18, and 0 times 4 is 0, and 18 plus 0 is 18. So that's my encryption, my encrypted message so far. And I guess what does that become? What, I got 9 again? That's not a great encryption, is it? Well, okay. Well, look what we got. We got 9, which is the letter I, and we got 18, which is the letter R. Okay, and then you keep on doing that, letter for letter for letter. Let's do it again for L and O. Well, okay, let's not do it again yet. Okay, so we could do it for L and O and V and E and O and space and Y and O and U, right? So that you do 2 letters at a time because it's a 2x2 matrix. The problem said to do a 3x3 matrix, but that's hard to invert. I want to decrypt the message too. So how do we invert it? Well, if you take the message 918 and say you want to decrypt it, if you have the encryption matrix, all you have to do is find the inverse matrix and multiply by the encrypted message, and then you should get back to the 9-0. And it's sort of, well, the only reason I got 9 here is because I got a 1 there. But now the problem is this. Make sure that your matrix is invertible, or you're not going to be able to decrypt anything. And the process of inverting a matrix involves dividing by the determinant. So make sure your determinant is not 0. So let's take a look at the determinant of this thing. So the matrix 1, 2, 3, 4, what's the determinant of it? Well, remember what you do is you take the what do? You take the product of the major diagonal, 1 times 4, minus the product of the minor diagonal, which is 3 times 2. So you got 4 minus 6 is negative 2. So since that's not 0, the matrix is invertible. Now how do you invert it? 1, 2, 3, 4. Inverted is, what you do is you take the major diagonal and you swap. So the 1 and the 4, you swap them. You take the minor diagonal and change the signs, so they get negative 3 and negative 2, but don't swap, leave them where they are. And divide by the determinant, negative 2, negative 2, negative 2, negative 2. And so what do you get? The inverse matrix is 4 over negative 2 is negative 2, negative 2 over negative 2 is positive 1, negative 3 over negative 2 is positive 3 halves, and 1 over negative 2 is negative 1 half. Now is that really the inverse? Let's see. Let's take the original matrix 1, 2, 3, 4, multiplied by the inverse matrix we just got, negative 2, 1, 3 halves, and negative a half, and see that we get the identity matrix, which would be 1 on the major diagonals, 1's on the major diagonal, and 0's everywhere else. So, let's see, how do you get first row, first column? You do first row, first column. So it's negative 2, and it's a dot product, so plus 3 halves times 2 is 3, so negative 2 plus 3 is 1. There you go, you get the 1. How do you get the first row, second column? Well, you take the first row times the second column as a row vector and a column vector dot product. So 1 times 1 plus negative a half of 2 is negative 1, so 1 plus negative 1 is 0. Perfect. How do you get the second row, first column? Second row dot product, first row column, column vector. And so you get negative 6 plus 6 is 0. Yeah, perfect. And how do you get second row, second column? We do second row, second column. So 3 times 1 is 3, and 4 times negative half is negative 2, so 3 and negative 2 is 1. So it works. Alright, so what does that mean? You're going to take the negative 2, 1, 3 halves, and negative 1 half. Negative 2, 1, 3 halves, and negative 1 half. Let's hang on. Let me just write this down someplace. Negative 2, 1, 3 halves, and negative 1 half. Okay. And you're going to take the 918 times that, and see that you get, what was it, 90, because it was I and then space. Let's see if that's true. What's the row column, the row vector, dot product, the first row vector, dot product, the first column vector is negative 18 and 27. Negative 18 plus 27 is 9. Perfect. And how do you get first row, second column, first row, second column? So row vector dot column vector, you get 9 minus, that's 9 plus 18 times a negative half is negative 9. 9 plus negative 9 is 0. Right, that does work. So the LR goes back to the, not LR, IR goes back to I space. Let's say this is a blank for space. And you can do that for every 2 letters. Alright, so let's leave it at that. That's just a proof of concept. We'll do a screencast day 10 part B, where I'm going to use Sage to do 3 by 3 matrices and encrypt the whole thing. Okay? Alright, so that's enough for now. I hope you liked that. I hope that was helpful. Bye-bye. Have a nice day, YouTube.